Okay, for the next example, so what we have is Josh and Mackenzie are friends again, so they've made up from the previous fight. And once again, they want to be standing next to each other. Felix, though, this is another one of the friends, demands to be on the far left. I shouldn't have used Felix, because that's another F. How many ways for the 6 friends to line up? So what we have is, I'm going to kind of draw this out a little bit. So we have our 6 slots. And then here we have Felix. So Felix is occupying the spot over here. He's on the far left. And now what we have is, with these things over here, we have 5 slots left, but we have, so what we're going to have is we're going to have the JM block with 3 of the other friends, so not Felix's. And so now we only have 1, 2, 3, 4 objects that are being maneuvered. So that's going to be 4 factorial, which is 24. But it could also be, we could also have Mackenzie, then Josh, and the 3 other friends. And once again, we have 4 objects, right? We have 1, 2, 3, 4 that could be mixed and matched. And so how many ways are there to line up 4 objects? There are 4 factorial, which is 24 ways. And it could be JM or MJ. It's 2 cases. So we add them up. And there's going to be 48 ways to do that. So there's 48 ways for line up 6 friends where Josh and Mackenzie are together, but Felix is on the far left. Okay, now what we're going to do is we're going to say Josh, Mackenzie, and Alex all want to stand together. So the 3 of them want to stand together. I'm not saying which order they want to stand together, but they want to be together in some way, shape, or form. And Felix no longer cares where he stands, so he doesn't have to be on the far left. And so the question is, how many ways, so from left to right as usual, for the 6 friends to line up? So what we have here is we have a block. And the block is going to be Josh, Mackenzie, and Alex. And so we have Josh, Mackenzie, and Alex, and then we have 3 other friends. And so we have the block and 3 things that can be maneuvered. And so that's going to be 4 factorial. So there's 24 ways, if it's precisely in the order, Josh, Mackenzie, then Alex. However, how many ways are there to organize that block? So let's go on another piece of paper for this one. So the JMA block could be Josh, Mackenzie, Alex, Josh, Alex, Mackenzie. It could be Alex, Mackenzie, Josh, Alex, Josh. You don't have to write this down. Mackenzie, Alex, Josh, Mackenzie, Josh, Alex. So if you count, there's 1, 2, 3, 4, 5, 6. Now we didn't actually have to write them all out. We knew that because how many ways are there to organize 3 things? Well, there's 3 ways to choose the first, 2 the second, 1 the first. There's 3 factorial. There's 6 ways. So going back to this, what we see is that we have the block and 3 other friends, which is 24 ways, but there's actually going to be 6 ways to organize that block. I'm going to run out of room here. And so each of those is going to be 24. So it's going to be 24 ways, and 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 24 ways. And we're going to add those up. Or another way of writing that might be, it's going to be the number of ways of organizing the block, which is 3 factorial, times the number of ways of lining up the 6 friends, including the block. And either way, you would get, if you did that, 24 times 6, you would get 144. So there's 144 ways to line up the 6 friends such that Josh, Mackenzie, and Alex are together in some way, shape, or form. I guess we don't really need this one anymore. Example 8. So this one you could probably pause after you've written it out and try it yourself. There's nothing really new here. 6 friends are lining up, but Alex wants to be 3rd from the left. No other restrictions. How many ways to line up? So we're going to do some dashes here. Let's try to visualize this. 4, 5, 6. And what we know is we know that Alex has to be third from the left. So I'm going to kind of block her in. She's not going anywhere. So Alex is third from the left. Now what we have is we have the other 5 people. We have the other 5 friends, and they're going to be going in the 1, 2, 3, 4, 5 slots. And that one's taken up, but we could kind of ignore it. There's really, or what we care about are these 5 places that they could stand in, and how many ways can we organize the people in those 5 places. And that's just going to be 5 factorial, which is 120.